Swiggy is a well-known food delivery and quick commerce platform in India. I'm sure many of us have used Swiggy to order food or groceries. And every time we do, those flashy offers pop up on our mobile screens, tempting us to place an order before the deals vanish. I'm sure you know that these deals are not created randomly. Platforms like Swiggy use a data driven approach to design these offers and customize them based on their user preferences. The goal is to retain the users and encourage them to spend more and more on the platform. So, it helps increase their overall revenue as well as revenue per customer per order. According to data published in newspapers, Swiggy handles 1.4 million food orders daily across India. That's nearly 1000 orders per minute. Last year, this number was 700k, and now it is doubled. They operate in 500 cities, partner with 140k restaurants, and have 200k active delivery executives. Incredible, isn't it? This clearly shows how fast they are growing, and to sustain this growth, they must have a powerful data and analytics platform to support their data driven decision making. Millions of users actively use platforms like Swiggy, and all their transactions like placing the order, etc., and mobile activities are stored in OLTP systems and some SaaS platforms, respectively. These OLTP systems could be one or more RDBMS under the hood to support transactional business processes. The transactional data that are captured by OLTP system then move to their data warehouse or data lake platform for reporting, advanced analytics, and machine learning workloads. To handle such high volume and high speed data, many of us might think of massive parallel processing, so called MPP, or distributed computing like Apache Spark or a Databricks, or cloud services like AWS Data Services or Azure Data Services. However, in this end-to-end data engineering hands-on tutorial, we will use Snowflake data platform where you don't need to worry about any infrastructure setup, and we will learn how easily you can build a powerful self-service data warehouse system in just few hours. You might be wondering why Swiggy for this end-to-end data engineering project. Well, to truly learn end-to-end data engineering, you need to solve a real-life business problem. And for that, you need some understanding of how a business application works and how it stores data before diving into the data engineering and analytics activities. We have all used Swiggy or similar food delivery apps. So, as we go through this project, it will be much easier to connect the dots and understand why we are doing what we are doing. Any food aggregator app will have a restaurant entity that will have catalog or a menu to serve the food. It will be clubbed with some discount and promotions. There will be orders, delivery locations, and payment activities. And then delivery executive will deliver the food and finally a rating for the service. It is also easy to understand that what kind of reporting requirement such food aggregator will have to monitor the health of business month over month. And hence, their founders and leaders would like to know total revenue, average revenue per order, average revenue per item, top performing restaurants, revenue trend over time, revenue by customer segment, revenue by restaurant and location, delivery performance, geographic revenue insight, and many more such metrics. And that's why we will use this food aggregator example to learn end-to-end data engineering work. So, who is this course designed for? If you are a data engineer or a data analyst or a SQL developer or a Python developer working on a data engineering project or a cloud developer and wants to learn how to build an end-to-end data warehouse platform using Snowflake, then this course is for you. If your next question is, do I need to buy any tool to complete this hands-on guide? The answer is no. We will use the free trial edition of Snowflake, which provides $400 in free credits and lasts for 30 days. All the exercise in this tutorial can be completed at no cost. Your only investment is your time. It is important to let you know what is not covered in this tutorial. When you say an end-to-end data project it starts with extracting data from source systems and pushing it to the data platform automatically. However, in this project, we will use synthetically generated data in CSV format of different entities. We will load this data using Snowflake's file upload feature via Snowsight Web UI, which allows up to 250 MB of data to be loaded at one time. If we have to visualize the overall architecture diagram of this end-to-end data project, this is how it looks like. We will load the data using Snowflake's file load feature into the stage location. After that, the data will go through a series of transformations, and finally, we will use the Streamlit app to visualize the KPI for the food aggregator business. A food aggregator platform like Swiggy has many business processes, and it is impossible to cover them all in one tutorial. So, in this guide, we will focus on their food ordering sub-process, the various tables and dataset that need to be ingested, and how they are interlinked in their OLTP system. Welcome to my channel, Data Engineering Simplified, the only YouTube channel offering practical Snowflake video tutorials for both beginners and expert data professionals. If you are curious where you can find source code and the data files that are used in this tutorial, please find the link below in the description section. And before we proceed, a quick note. All the hands-on exercise are done using Snowflake's free trial Enterprise Edition hosted on AWS. I suggest watch this video in 4K resolution. And if you are a fast learner considering speeding up the video to 1.25x or 1.5x, you can also change the language and listen the tutorial in your preferred language like German or Hindi. If you are looking to learn in a more structured way with complete source code and data files, be sure to check out my courses on Udemy, and some of them are also available through Udemy Business. All of my courses have a rating of 4.7 or higher. For queries, suggestion, or feedback, drop a direct message to my Instagram account. The link is given below. And yes, if you would like to stay updated on Snowflake new and popular features, end-to-end data engineering projects, architectural concept, live demo videos, don't forget to subscribe to this channel, Data Engineering Simplified. So, let's start this tutorial. So before any food order is placed, food aggregator needs to target a location where they will serve. Once location is finalized, they onboard restaurants. Each restaurant then will have their menu uploaded into the system. Then the customer will log in using their email or a phone number, create a customer profile, including their delivery location or so-called customer address. Then, this customer will search and place an order. Once order is placed, the delivery agent will be picked for delivery, and then delivery will happen. So, if you look into this picture at very high level, minimum 9 to 10 such entities or tables are involved to support their order business sub-process. In real life, it would be much more than this table, but for this tutorial, we are considering 9 to 10 entities. Now first, let's go through the ER model that represent these entities with relationship. I am using dbeaver Community Edition to draw this ER model, and I am assuming my OLTP system is hosted on a Postgres RDBMS database. And if you use dbeaver and if there are relationship between the tables, this ER diagram will come automatically. You don't have to draw that, and using reverse engineering, you would be able to get this diagram through dbeaver. So this is my customer entity, and each customer has one or many addresses. So there is relationship between these two entities. Here on the other side, I have this restaurant, and each restaurant will have menu item. Again, this is one-to-many relationship. And on the other side, we have this delivery agent, and this is my delivery table. Whenever an order is placed by the customer, the order table gets one record, and order item may get one or more record based on the number of order item per order. And this is again one-to-many relationship because each customer may log in multiple times during this order process. And this is my location entity where the location is tracked. So when I click on this thing, it says customer has a relationship, and this is one-to-many. When I click on this customer to log in, and here my customer to order. Likewise, if I say this is menu, this is order item is also linked with menu, and here this is order to order item, this is my order to delivery, and this is my delivery to delivery agent. So whenever you are working on any data engineering project for any domain, it is very, very important to understand the source system ER diagram, because based on that relationship only, you would be able to design your data warehouse table under different layers. Let's see how the data looks like quickly. So if I say customer, this is how the synthetic data looks like. Here I have a customer ID, customer name, mobile, email address, a login using Gmail or Facebook account, and this is gender, date of birth, anniversary, and different food preferences when this record is created and when this record is modified. Okay. Now going to the customer address book. So here I have customer ID as a foreign key. Rest of the information is available here, like flat number, house number, floor, building, landmark, and this. If you pay attention, this is a number field, this is a text field. And so this tool also helps you to verify the data type, and you can decide by looking at the data type what kind of data type you will have it when you host this data into your data platform. Now let's quickly see the delivery agent. Now this is the delivery agent, where delivery agent ID is a primary key. Then we have a name, phone number, vehicle type, location ID, status, rating, and created date. If I go to the delivery, so here when I talk about delivery, so delivery is a transaction table where every delivery will be mapped to order ID and it will be delivered by a delivery agent. So this is a child table of order and delivery agent, and for every delivery primary key, you will have this foreign key associated with that. And here we have a delivery status, estimated time, and address ID, and so on. Now let's talk about restaurant. So here for our end-to-end data processing, we have generated quite a lot of synthetic data, and this data only belongs to location New Delhi, and we are not considering all the cities. So for a simplicity, I am only considering one location, and these are the number of restaurants we have it under this location. So this is a master table where you have the name of the restaurant, type of restaurant, pricing for two, okay, and restaurant phone number, operating hours, location ID. If you see, the location ID is always 1 because this belongs to one location. And then we have active flag, open status, and all those things. Again, this is a completely synthetic data. If I go to the location, let's see how the location looks like. So if you see location, I have a Delhi state, zip code, an active flag, and all those other information. And this is a standard created date and modified date, which is all technical field. So this is my another master table, okay, and this will be converted into a location dimension when we get into our data warehouse platform. Now let's go to menu. So menu is a child master table, and here this is a restaurant ID, okay. So for restaurant 1 I have 2 menus, restaurant 2 I have quite a lot of menu, again restaurant 5 has a menu. So the data is not very consistent. This is for only the demonstration purpose, but this will be converted into another dimension where we move this into Snowflake data warehouse platform. Now let's go to the order. So when you look into the order ID, which is a primary key of this table, each order belongs to a single customer, and I can have many orders for one single customer. Then they will place an order from a particular restaurant. So this is a restaurant ID foreign key. This is a date when the order is placed, the total amount, what is the status currently, payment method. So these are the important information. This is not a master table. This is a transaction table. Now let's see how the order item looks like. So one single order can have multiple order item. This is a menu ID because you can have one or many order item as a part of your order. This is a quantity, a total price, and subtotal, and when it is created and when it is modified in case if it is. This is also a transactional table. When we are going to create a fact and dimension, the fact granularity will be at the item level and not at the order level. So every enterprise grade data project start with source analysis. Sometime you may have access to the ER diagram of the source system, and sometime you may not have it. However, you need to understand the relationship between two tables and what is the data type, what is the volume of the data, how the data is being generated, whether it is a master table or a transaction table, because this information is very, very important to map it when you try to create dimensional modeling. And we will see that at the later part of this video. So in this section, we have already seen how the ER diagram looks like for our food aggregator system. and how the data looks like. So the first part of tutorial will deal with subset of data, and we are going to see them in a CSV format. So let me jump into my VS Code editor and show you how those sample data looks like. This is my VS Code editor where I have already kept those generated data under different folder. In this end-to-end data project, we will demonstrate how we can have the initial load and then how we can process the delta load, which is a very common pattern in many batch processing system. This is my location data, restaurant data, customer, customer address, menu, order, order item, delivery agent, and delivery CSV. For each of this entity, I have handful of record. So first we will build end-to-end solution. Then we'll go and try to load thousands of record. And this is a common practice in any data engineering project where business team will give you a sample data set, and based on the sample data set, you will build your entire end-to-end data pipeline. And then once it is deployed, you would be able to validate a large data set. So if you look into this location, I have this location 5 rows CSV, and then I have delta data which simulate insert as well as insert followed by update. Likewise, if I go to the restaurant, I have only 5 restaurant, and then in the delta file, I have again handful of restaurant. Then this is my customer where I have this customer detail, and then you can see customer insert and customer insert update. Then I have customer address. Then we'll go to the menu. This is how the menu looks like. And if you see here, I have some invalid record, and in any data engineering project, you will see a lot of inconsistent data set which you need to handle as a part of your transformation layer. Now I have handful of order here. Then I have the delta order coming in 2 different files. Likewise, we have order item, and then you have order item delta files. This is the delivery agent, and this is the delivery agent delta files. Finally, we have delivery transaction table, and these are the 2 delta files. This is how my CSV file looks like, which is exported from my Postgres database as a handful of record. Now let's quickly understand the overall end-to-end data architecture for this food aggregator data platform. We already have a lot of CSV file per entity, and those CSV file would be loaded through the file loader in Snowflake. Those CSV files would be finally placed into the stage location, and from the stage location, we will run the copy command, and that copy command will load the data into a table. Now, from the table, the data will move further under the clean layer, and this clean layer is nothing but a schema where we will do a basic cleansing processing and transformation. And from this clean layer, the data will finally move to the consumption layer where we are going to perform the fact and dimension table. We will go step by step, starting from our location entity till our order item fact table. Once the data is available in fact and dimension table, we will create some view and display the data through our Streamlit app for our end user. 90 to 95% of data engineering project will follow this architecture where you may have a slightly different naming convention. Some organizations say raw or stage. Some organization will give the name called cleansing curation, and here in the consumption, they may give a name called moderate layer. If you follow the Databricks architecture, they call this architecture as a medallion architecture where it start with bronze, then silver, and then gold. As you go from left to right, the data quality increases and become more and more consumable. At the end of this process, what we are trying to achieve by following this overall architecture, our primary objective is to consume source data into a data platform, and after it goes through set of transformation, it will form the data which follows the star schema dimensional modeling, where you have all the master data like a customer, customer address, restaurant, menu, restaurant location, delivery agent will be converted into a dimension table, and order item along with order table will be converted into a order item fact table. So your clean schema would primarily represent the OLTP style dataset, and your consumption schema will have the data available in form of dimensional modeling. So let's go to our Snowsight web UI and start working on a code. So this is my Snowsight web UI, and I have already created different worksheet, and each of this worksheet will help us to create different object under different schema. So this is my first script called create database and schema. And as a part of this script, we are going to create a database called sandbox. And that is what we generally do. And inside the sandbox, I'm going to create stage schema, clean schema, consumption schema, and one schema called common, where all the common object would reside. So let me shrink the left panel. And first, let me switch the role. Now my role is switched, and I'm also going to choose a different virtual warehouse. So I will do ad hoc virtual warehouse. Now let's create a database called sandbox, and I will first use this database. So if you notice, my context got changed to sandbox.public, and public is a default schema here. And I'm going to create the 4 different schema called stage schema, clean schema, consumption schema, and common schema. If you look into our architecture here, so I have created stage schema, clean schema, consumption schema, and one of the common schema that will hold all the policy object, another common object, which can be accessed by any of the schema in our data flow. Now I will run this use schema command. Now here my schema is stage schema. And as we are going to process a lot of CSV file, I'm going to create a file format called CSV file format. So Snowflake supports 6 type of file format, and CSV is a very common one. It also supports Parquet, JSON, XML, ORC, Avro. And if you are not familiar what is the use of this file format and what is the use of stage location, I would suggest you to go and watch this particular video. Now I'm going to create a stage called CSV stage, where we are going to load all the CSV file what we have reviewed at the beginning of this tutorial. And I'm also enabling the directory service. So this is created. Now this is another tab where I would like to see the sandbox database and all other schema. Let's refresh it. So this is my sandbox database. This is my stage schema, followed by clean schema, followed by consumption schema, and this is my common schema. If I go inside this stage, I have this one CSV stage visible and another is file format. And this file format will be helpful to parse our CSV file when we are loading them through the copy command. I'm going to create a couple of policy tag, and we will see how this policy tag will appear when we attach them with the table. If you're not familiar with the tag and masking policies, I would suggest you to go and watch these videos which covers tags and policy in detail. So my policy is created under common schema, and let me select all of them and run it. If I refresh, let's see whether those policy tags are visible here or not. Policy tags are in general not visible as on today on Snowsight web UI. So as a first step, we managed to create a sandbox, couple of schema, stage environment, an internal stage, and the file format. So stage schema is created, clean schema is created, consumption schema is created, and this location is also created. Now we are going to use the file upload feature and try to load the data into this stage location. So that's our next step. You can find all the scripts available in my blog. Refer the link below. The step 1 script is already available, so you can go and copy paste them. And before going to the next step, please make sure that these objects are available in your Snowflake data platform. So now we got our stage location, which is called CSV underscore stage. This is an internal Snowflake stage where we can load the CSV data. So since we have a 2 type of data files as we have seen, the first data file we call it initial load, and then we have delta loads. So we are going to create two different partition. One is called initial and second is called delta. So let me click on this plus files, and here this is my sandbox dot stg stage underscore schema is already selected, and this is the location where the data would be loaded, and here I will give initial. The first I will start with location, and I will quickly drag drop the location file. So this is a location file, and this location file will be residing under folder or a context called initial followed by location. So this is my initial. Likewise, I will create a delta and I will drag drop all the file from my location delta folder. I have multiple files and I will demonstrate you how the copy command works when you try to load the invalid file or duplicate file. Here, it will also go under the context location. Snowflake is very fast, so even if you have a 100 MB or 200 MB data file, it will be loaded very, very fast compared to any other platform. Now, let me shrink this. So this is my stage location. This is my context initial. This is my another context location. And then I have this location hyphen 5 rows.csv. Likewise, I have this delta. Inside delta, I have a location. And inside location, I have a multiple files. So my location data is loaded. Now I will follow the same process to load other data file, and I will do it in a fast forward mode. So for this tutorial, we are only and only focusing on, or I would say, one location at this stage to keep the tutorial simple and easy to understand. Now, here you can see my another context under this initial is created. So as I add more and more file, I will always create a context, and under the context or a partition, I am going to place the file. Let me go. How does it look like? So here, this is restaurant Delhi plus NCR. Here I have two files. So now you can see this is my stage location. This is the delta as a partition or a context. Under that, I have two different context or a partition, restaurant and location. And inside restaurant, I have these CSV files. Looks good. Now I will go ahead and do for other data file. So you can see total 10 initial load CSV files are loaded. And this is again following a different partition. So it is easy to understand. One thing to remember, when we are going to run a copy command, we need to make sure that we do not follow the pattern and we will follow the exact path. Because sometime if I follow delivery, it will consider both this location and will try to copy all the CSV file available under this. These are the small things you will only come to know when you work in a project like this by doing yourself. Otherwise, and if you are going to appear for Snowflake interviews, and if somebody asks what kind of challenges have you faced, you can clearly tell them these are the challenges we have seen while loading the data or while processing the data or while transforming the data. Now I'm going to load the delta files quickly in a fast forward mode. So this is a delta and I have only restaurant and location. I will quickly process other 8 delta files. So for every entity, I have two delta files. Primarily, one delta file represent your insert operation and another delta file will represent insert or update operation. And when we are trying to follow the STD2 slowly changing dimension type 2 architecture in our consumption layer, these sample files will help you. Another important thing to remember, in any SQL based tool, order is a keyword, and that's what instead of giving order, I have given orders. And again, when you are following these naming conventions and partition, make sure that you cover different kind of scenarios and accordingly you create a pattern for your project and then follow that pattern for all the stage location or a table or a schema. So here we managed to load total 23 files, and these 23 files are part of this total 10 partitions or so-called context. So when we are going to use the copy command, we are going to follow stage name followed by delta or initial followed by name of the entity, and then we are going to specify the name of the CSV file, and then we'll run the copy command. Snowflake has recently added this feature called Lineage. And if you want to know more about Lineage, how does it work, you can refer this particular video, which primarily focus on this data lineage and how it works in Snowflake. And as we progress in this tutorial, we are going to use the Lineage feature to understand the overall flow and validate that flow with our architecture. So in this step, all the CSV files are loaded inside initial and delta location. So I would say this part is done. And in the next step, we are going to create tables for each entity and run a copy command, and we'll see how we can utilize the stream object to capture the changes while loading the data. Let's quickly explore one more thing, how you can check the files which are available in your internal stage or external stage. For that, Snowflake gives a command called list followed by @sign, and then you can give the name of your stage location, either fully qualified or just the name of the stage. So we know that we created our stage location inside this stage underscore sch, and the name of the stage location is CSV underscore stg. So if I run this command, let's see what result does it bring. I can see total 33 files are available. All the files are loaded on 1st December 2024 Sunday. And here I have this delta partition followed by customer address and so on. All the file size are available, including the MD5. If I have to narrow down and check how many files are available under my initial partition, I can add the partition name, and let's rerun the query. Now I can see only 10 record and all the partitions with initials are available here. Remember, whenever you are referring to this stage location, this is case sensitive in Snowflake. So if it is lowercase, you have to follow the lowercase. If it is uppercase, you have to follow the uppercase. So during your interview, if somebody asks you, is stage location files are case sensitive or not, you have to say yes. You can also use the remove command to delete the file, or from the web UI, you can also click on triple dot and delete the file. You can also download from there. So you can remove it, or you can go to a particular file, and with triple dot you can download, or you can load into a table, or you can just copy the path. Okay, now it is also possible that you can query these stage location files without loading into a table, and for that you can use this dollar notation. So you have to write select the name of the column as we have shown here from stage location. So this is the schema name, this is stage location name, this is the partition initial, and this is the partition location. And I can attach a file format, and this file format understand what is the CSV file. And if I go up here, we have created this file format where type is CSV, compression is auto. So whether it is CSV or gzip, it will, or compressed file, it will understand. Delimiter is comma, record delimiter is new line. Skip header, yes, it will skip the header. And if the description fields are enclosed in double quote, then I have to keep this code. So this is what the definition of my CSV file. So if I run this, let's see what happens. So it is clearly representing the location data which we have seen. So this is my location data. First line is skipped because it is a header, and rest of the 5 records are available. Looks good. If I make any mistake, for example, if I give a capital N and try to rerun this, it will not bring any result. So you have to be very, very careful with your stage location, partition name followed by your name of the file. I can also go and so let me pick this file name and I can give very specific file name if I have a conflict with my partition name, and I can rerun this and I will still get the same result. Always remember, since we are running a query and getting the data from the stage location, this needs a virtual warehouse. And if you do not have a virtual warehouse, you may not be able to run the query. So we finished creating database object, different schema object, stage location, file format. We loaded the file into the stage location. And now we are going to process each of this entity one by one until we reach to the consumption layer. And in the next step, we start with the location, which is our topmost master information in this use case. This is my next worksheet called location entity. Let me shrink this. And first, I'm going to change my context. So this is my sandbox stage schema. This is the role and this is the virtual warehouse. All looks good. We have already tried this query where we are trying to fetch the data from the location CSV file. Let me rerun this. So I have total 5 record, looks good. So whenever we are loading the data from stage location, it is important that we add some additional column, which is called audit column. And this audit column captures your file name from where this data is coming from, what time the file was modified, what is the MD5 value, and the timestamp when the file is loaded. So let me run this query and show you the result. So let me shrink this. So this is the stage file name. So in the next time, if you're going to load the same file by running this query, you would be able to understand where this record is coming from. And this is a load time, and this is the MD5. This is the time when we queried the data. Okay. So let's go through this architecture diagram once again, where we will look from the lens of location entity. So first we loaded this location CSV file into the stage location. So this is available here into this stage location, which is my CSV underscore STG. From here, we will run a copy command, and that copy command would follow the select structure, what we have just seen. And from there, we will move the data to this clean schema, and from the clean schema, we are going to create location underscore tim table. Before we run the copy command, we have to create this location table. Along with the location table, we are also going to create a stream object, and stream object will help us to track the changes. And if you do not know how a stream object works in Snowflake, I have couple of tutorials which had already explained the stream object in detail. And from this stream object, we are going to create a next location table under the clean schema. And when we go to the clean schema, the primary objective of the clean schema is to have the appropriate data type. And from there, we will create this location dimension table with hash key. So let's go back to our worksheet. So this is the DDL for my location table, where location ID, city, state, zip code, activation flag, created date, and modified date. These are the domain entities, and all of them are having a data type text. And this is the additional technical column, which generally I prefer to give with underscore. So you are very clear that these are not coming from the source system. Good. And this is the comment. Now let me create this table. So my table is created successfully. Let me refresh. This is my another tab, and let's see my location table is created and the description is visible and all the columns are visible. So I have total 11 column, and I can always go back and check all the column names are matching as per this CSV file definition. Looks good. I have total 7 column coming from the location entity and 4 column which are technical columns. Before I do anything, I am going to create a stream object, and the primary purpose of this stream object is to capture any change which happens to this table. And once we run the copy command, you would understand why this stream object is created. And this stream object is created on the location table, which is this particular table, and the property append only is true, and this is the comment. So let me create this stream object. So this also got created. When I switch my tab, I can see here I have a stream object and it is created on the location. This is the copy command where I am loading these specific columns, and this is my dollar notation to fetch the data from the CSV file, and this is the location of the CSV file. I have just given the partition name, and this is the file format, and in case of error it will abort it. So this is how the copy construct looks like in Snowflake, and as soon as I run this, let's see what happens. So this is the file which is being processed. The status is success. It means all the records are loaded, and this is the total number of record which got loaded. I can go back to my table page and let me refresh this. And when I click on this location, here I can see total 5 record got loaded. And let's see how the data looks like. So I got all the data, and here is my audit column shown. So data is loaded on this particular time. And if I click on a copy history, I would be able to see that this particular file is copied. And if I click on the lineage, this is a table lineage, and it clearly says that this table is populated from this stage location. Looks good. I can run the select statement here, and I can see the data, and I can also run the select statement on the stream object. Let's see what result does it bring. So it has brought exactly the same data set. I will show you the difference. So up to here, I have total 11 column, and these 3 columns are added by the stream object, and it clearly says that whatever operation you will perform on the main object, stream object will capture that, and I can run a query on the stream object and push the data from the stream object to the next layer. So if you look into this diagram, this is my stream object, and when I'm going to populate data to my clean schema under location table, the data will not come from this location table. Rather, it will come from this stream to the location table. And I will show you what do I mean by that. Coming back to my location worksheet, here first of all, I will change the schema name to clean schema. Now you can see my schema name got changed. And here I'm going to create exactly same table. The only difference you would notice that here the data type is not text, and the data type is matching the expected data type from the source system. So location ID is number, city, state, code, they are all following the source system data type, including the limitation. However, here I have added some additional information which says whether it is union territory or not, whether it is a capital city flag or not, zip code, and additional things, right? And we will see how we can enrich the data into the clean layer. Okay. And here every clean table will have a surrogate key, which is nothing but auto incremented and primary key for this table. Location ID should be the unique in this table. So this is how this table looks like. So let me create this table. So this location table or a restaurant underscore location table is created. Let me refresh this. And I come here, and I can see I have a restaurant location table. This does not have any data at this stage. And I am also going to create a stream object called restaurant underscore location underscore STM. And this stream object is created on the restaurant underscore location. It means that any kind of change, whether it is insert, update, delete, this stream object would be able to capture that. So let me do that. Quickly refresh to check. Yes, my stream object is available. I'm going to run a merge operation, and that merge operation will load the data into the restaurant underscore location, where it is going to run a query, and this query is running on your stream object. Let me show you. So here if you see, this is a stream object, STG stream object, and in this query it is trying to enrich the data. So here I have added couple of case statement. If it is Delhi, then make it New Delhi, and for other state it will retain the same text. When I'm adding a new column called state code, likewise I am also adding another field called is union territory. So if any state matches with this name, it will be flagged as a yes, otherwise it is no. This is another case statement. The state is this and city is that. Then we have another called capital city flag. Likewise, if it is a tier 1, tier 2, tier 3 cities. So these different additional columns are added to this. And when the location ID matches with the location ID of the source, if any changes are being recorded into the source table, then it will be updated. If the new location is coming, then there will be insert operation. I assume you are fully aware how the merge operation works. You can pause and go to my blog post and go through the query to understand how this merge statement is running on the stream object. Let me run this merge statement. So it says 5 record inserted and there is no update because our data does not have any update operation. So looks good. Now let me refresh this, and sometime you may have to refresh the entire page because this only refresh the object entries, but it does not refresh this page. But if I go to the restaurant location and this is still showing 0, so let me refresh the entire browser page. Now I can see total 5 record. If I click on a data preview, so this is looking nice. And if I see the column, I have total 16 column. I added some additional column and let me see how does it look like. So if you look into this, the state code is added. Is union territory true or false? Is a capital flag true or false? And if you see that this is false because in union territory we do not have a capital, but we can change the case logic and make sure that this stands true. And then I have a different tier 1, tier 2, tier 3 city, and this is a zip code. Likewise, active flag, yes, right now only New Delhi is an active city where this food aggregator is serving. All other cities are having a no flag. Okay. And then these are additional information. Looks good. So coming back to my diagram, from the stream object, we ran the merge operation to populate the location, and this location table clean schema also having a stream object. So any changes done on this location table can be tracked by this stream object. So as a next step, we are going to create a location dimension table, and location dimension table will also take the data from the stream object, as stream object only shows the changes and not the entire data set. And that's what we need to have it whenever we are going to process the delta. So let me go back to my worksheet. So before we run another merge operation where we are going to load the data from clean location table to location dimension table, this is how the DDL looks like. If you see, I have a primary key which is called restaurant underscore location underscore HK, and then all other data set is available here. And to track the slowly changing dimension, I am having effective start date, effective end date, and current flag, right? So the location information may change over a period of time, and to make sure that we track those changes, we have to follow this SCD2, and these are the column which we added into our dimension table. So let me create this table first. So my table is created, and now I have another merge operation. If you look into this merge operation is trying to insert the record into my restaurant location dim table, and it is querying the restaurant underscore location underscore STM. And let's see what data set do I have. So I have total 5 records available here. And if I look into this metadata column here, metadata action says all the records in the stream objects are insert operation. None of them are update. And this is the row ID. Looks good. Now, if you look into this, so basically this merge operation will join this target table and stream object table, and it will try to fetch if the location ID matches with the location ID between these two table. And when the metadata action is delete and metadata update is true, it means that record has changed. So it will make effective end date equals to current timestamp and the flag equals to false. In the sense, this row is no more valid row. If it does not match and it is an insert operation and is update is equals to true, it will insert a new record. If it is completely new location, then it will primarily insert the data into the dimension table. And first, let me run this query. And when we load the next set of data, you would come to know how this merge statement is actually performing. Let me select this. So whenever we run a merge operation, it always shows a number of record inserted and the number of record updated. Right now, we are doing an initial load. We are not observing any change on an existing record. That's why our update values are 0. Looks good. Now we will see how our dimension table looks like. So let me refresh this, and under the consumption schema, I should see one location table. So I have a restaurant underscore location underscore dim. Looks good. And when I click on that, and let me see the data preview, I have created a hash key, and this is my restaurant location. And if you see, these are my location ID, which I'm keeping it as is. And this is the city: Delhi, Mumbai, Agra, Ahmedabad, Ajmer, and this is a state. And this is how the data looks like. This is the active flag, which is coming from the source system. And all these records are effective start date of this record is this, effective end date is null, and this is a true. It means that if any changes happens to any one of the record, this particular row item will set the effective end date and the flag will go to false. It means that do not refer that record. Now, if I click on the lineage, you would be able to understand how the data is flowing. I can click on this plus sign, and I can click on this plus sign again, and this plus sign, I do not have any upstream. So this location dimension is created from this restaurant location under the clean schema, and this is populated from this, which is again in the stage schema, and this data is coming from this stage location, which is this. So if you see, this is a stage location, this is my table, this is another table, and this is another table. If you click on this is the description of the table, and the number of total column is 13, number of rows are 5. And if you would like to know where is this state code coming from, I can click on it. I do not have any downstream lineage. I can click on upstream lineage, and it will show that this is coming from this restaurant location under clean schema. Looks good. However, if I select city and click on this view lineage, click on this upstream, and if you see, distance is 1 and 2 because city is not the derived data, and this is coming from a location table under stage schema. So if you look into this lineage, this matches with our lineage, okay? And this is what we managed to achieve. And this is the same process we are going to repeat for all other entities. Here we did not follow any primary key, and we just kept the source data as is by adding some 4 extra column. When we came to this location, we added some additional field along with data type changes. And when we came to this location dimension, which is following the SCD2, so this table will always match the source table. However, this table will track all the changes, and the number of record between these two tables will always vary. Now let's go and push some delta record. Let's see what happens. So now I'm going to process this delta day 1, which has only 2 record, and then I will process delta day 2, where I am making some changes, and these changes will say this cities becomes active. It is going to add 8, 9, 10 as insert, and these are the changes. And let's see how these two files works when we use the stream object as a tracker. So if you look here, I am running a list command on my delta location, and let's see how many files do I get it. So I have so many files. I'm going to pick my day 0. Let me copy this entire location, and then I can change this location up to CSV file. This is going to the delta folder, location folder, and this is the name of the CSV. And now let me run this copy command. Before I run this copy command, which will load the data into this location table, let me quickly query the location table and location underscore esteem table under this stage schema. I have total 5 record, and all the data is coming from this initial location CSV files. My stream object is completely empty. It does not have any record. Now, let me run this copy command. And before running this copy command, if I check my copy history, it has only one file. Now, let's run this. So it says 2 records loaded, which matches with this 2 record, looks good. Now, if I go to this location table, I have 2 record number location ID 6 and location ID 7. And again, when I'm talking about a stage location, it is having exactly the same representation as a source. So looks good. And if you look into this stage file name, it is telling that these 2 records are loaded from this CSV file at this particular time, which is, and if you look into this time is having a different timestamp. So when you're trying to debug where this data set is coming from, you can really run a query on this technical column and understand where from which file these rows are populated. Now pause and think what would be a location underscore stream object bring when we run a select statement. Since we inserted only 2 record into the main location table, or we call it base table, the stream object captured only the insert operation, because that's what this stream object is designed for. And that's what we need to push the data from our stage layer to the clean layer. Right now, I have only 5 records into my clean restaurant location. And I'm going to run this merge statement again. And this merge statement will pick only the 2 record from the stream object and insert into the restaurant underscore location table inside the clean schema. So let me run it. Since it is a merge operation, it says 2 record inserted and 0 updated. Looks good. Now let me reload the entire page. Now this also got all the surrogate key starting from 1 to 5 and then 6, 7. And I can see my data set is populated clearly and all of them are looking good. Okay. Now I need to make sure from this stream, the data is consumed and goes to the location dim table. Let's try that out. So if I run the select statement on my restaurant underscore location underscore STM, I should expect to record. Looks good. And this to record will move to the dimension table through this merge statement. So let me run it. Now I can see 2 record inserted and 0 rows updated. Now let me go to the consumption schema and see how this location dimension looks like. So here I can see also location ID 6 and 7, and this is my hash key. Here my SCD2 columns are looking good. We managed to process this newly coming record through this day 01 CSV file. Now, if you look into the day 02 CSV file, it has 3 new record, location ID 8, 9, 10, and it has 4 old record. And what this old record says, it is primarily making the active flag equals to true, which was false in the first case. So this 4 location ID will also be true. Again, this is a very hypothetical case, just trying to show you how this delta processing through the stream object really captured your slowly changing dimension in your consumption layer. So let me run this list command. And this is my delta 2. So I copied the name and I just change this. And if I run into my location stream, I do not have any data because I already consumed that. And I am going to run this copy command. So 7 rows loaded, which is here I have total 7 rows because I can skip the first header row. Now, if I run this statement, again, you can pause and think for all insert, since it is a insert append only stream, I will have only 7 record. So here all the flags are yes. So when this stream object is going to be joined with restaurant underscore location table, it will compare which location ID already exists into my clean schema. If it exists, it will pick the changes and the changes will be applied. And if it is a newly inserted record, which is 8, 9, and 10, it will get inserted into this one. So here, if you see the modified date is also coming from the source system, but here there is no modification, it is coming null. Looks good. So let me run this merge operation and this will populate those 7 records by following this approach. If the location ID matches with the location ID, but any one of them got changed, then it will run the update statement. If not, then it will run the insert statement. So I am running this merge statement. 3 record inserted and 4 record got updated. Looks good. So this is the 3 insert and this is your 4 update. Now for dimension table to capture those update and insert, let's see how the record looks like in the restaurant location stream object. So I'm going to pick one example, Mumbai. So there are 2 record because this record got updated, and so I just applied a filter. And if I look into this record, and if I look into this stream metadata operation, first the stream object record the delete operation is updated flag is true. And for the second new record, it is called insert update operation is also true. And if you see the change, initially the active flag was no, which got a delete flag. And when the new record, which has captured the active flag equals to yes, this is coming as an insert as a part of update. So this is how the stream object captures the detail. So now I'm going to run this merge statement, and you can go to my blog page and you can understand how this merge statement is written. Let me run this. So total 7 record inserted and 4 rows updated. So when I say 4 plus 3 equals to 7, and to understand more, let's see how the data set looks like. So let me show the entire table first. Uh, so if I look into this example, Mumbai, and initially Mumbai was having a no active flag, now it is having a yes active flag. And if you look into the result, here it current flag is true and here the current flag is false. And whenever a change happens, effective end date column gets a value. Okay. So this is how we managed to get the SCD2 implemented in our location dimension table. Our entire data is flowing from source location to the stage location. Through the stream, it is getting into the clean layer, and again through the stream, it is getting into the consumption layer. We are also able to get the SCD2 type in our location dimension. So now we managed to cover location dimension. Let's go to the next object, restaurant, and we are going to follow the same process, and I'm not going to explain everything in detail. Before we go to the next entity, let's try to simulate if we run a copy command with invalid data, what happens to entire flow. This is another delta file called delta-day03, which has invalid delimiter. So if you look into the delimiter, it is a pipe sign instead of comma. Let's say your data platform gets a data like this. What would happen? Let's try that out. Let me go back to my worksheet. So this is the file, and let me copy it. I copied name, and here I pasted the name. And again, I would like to check if I have any data in stream. I do not have any data in my stream. Now I am running this copy command. So it says 3 rows parsed and 3 rows loaded, because if there is no comma, in that case, all the data set will be loaded into the first column. Now, if I look into select a star from this location, so if you see into this 3 option, I got incorrect data. Now my stream will also have the incorrect data because all the columns are coming filled into the first column. And if you look into this, this is coming from invalid delimiter. Now I'm going to run my merge statement and let's see what happens. So here it failed because it says that numeric value cannot be recognized. Okay. And since this statement got failed, my stream object will still have the data and it will not be cleaned up. Now, I would allow you to go and think, how would you solve this problem? This is one of the common problem when we see that if bad record gets into your system, how would you handle that? But somehow I need to clean this stream data, otherwise it will continue to fail and it would not allow me to proceed to the next level. So I created a location underscore temp table through the stream, and by that I consumed all the data from my stream. My stream is clean now. However, my location table is still having the odd record, so I would go and delete that odd record from the location table. So wherever I have this pipe sign, those record would be deleted. So it deleted 3 records, and since my stream object created on the top of location is happened only, this would not be recorded. Let me reconfirm this. So I do not have. Now this is my fourth day invalid file. Let's see what happens if I try to push this. So I ran the copy command with that file, and it says 4 rows loaded. And if I go and the select statement, I can see this chunk data got loaded into my system. And likewise, my stream will also have this dataset available, which is not right. And again, when I try to run this merge state, since it will not get converted into a number, this merge statement will fail. Let me run this. So numeric value is not recognized. When you're trying to run this entire process through orchestration tool, you need to make sure that you run the copy command only when you have a clean data. Otherwise, your merge statement will continue to fail. So let me clean this once again. And I will use the word junk. So whenever you are building an end-to-end data pipeline, there could be many such scenarios which you need to simulate in advance, and accordingly you have to write your merge statement, or you need to have a SQL statement which would check whether it is possible or not. One of the possible solution, you can try to cast it, and if the cast is not possible, instead of on error you can say continue. That way you can solve this problem. So only those record which qualifies this check will get into the stage table, otherwise it will not. We finished the location entity to be loaded into our Snowflake environment and converted this master data into a dimension table. Now, let's work on the restaurant entity, which is another master data set. Here we have quite a lot of column. We are going to load this data and follow the similar pattern what we have seen and done for location entity. Our objective at the end of this section is to convert the restaurant master data into a restaurant dimension. And here we will have a hash key followed by restaurant ID and rest of the information about the restaurant. For restaurant, I have this initial load, which has total 5 records starting from restaurant ID 1 to 5. Then if I go to the day 1 delta record, it adds 3 additional restaurant IDs. And if you look into the third day, I add 2 additional restaurant, but there are some changes on restaurant ID 3, 4, and 5 just to simulate if our SRE2 is working appropriately or not. So let's go to our worksheet. So my context is already set. This is my restaurant entity worksheet, and this is my system admin ad hoc virtual warehouse. So I'm going to create a restaurant stage table, and all the column are text value. If you look into this restaurant phone number, I am adding a tag where the restaurant phone number is a sensitive information, or this column is classified as a sensitive, and you will see how this appears on the table description page. So this table got created successfully, and now I am going to create a stream object on the top of this restaurant table. So I can see a restaurant table here, and all the information is visible, looks good. Likewise, I have the restaurant stream also available. This is looking good. Now we are going to run a copy command, and this copy command will have all the domain entities from the restaurant and these 4 additional columns which we are going to add it. And let's run this copy command. So my copy got executed, total 5 rows loaded. When I come to this table, I can see. So these are my 5 rows. All the data got loaded successfully, no issues. If I look into the copy history, it also looks green. Great. Now you can also run this information schema table function to check whether your copy executed or not, rather than changing the screen. And let me run that. So it will show that where this copy command, so what is the file name and what is the stage location and the load time and all other detail. Now next I am going to create exactly the same structure of a restaurant table. The only difference is that this time I am using surrogate key as a restaurant surrogate key, auto increment primary key, and all the informations are almost same. And now you can see I have applied some data type and some additional constraint, and I'm keeping the same tag or restaurant phone number. Now let me create this quickly. So this got created, and I'm also going to create a stream object. So this also got created. Now this is the insert statement which you can do, or you can also run the merge statement as we have done earlier. So if you look into the merge statement, it will select from the stream and it will try to cast, because this time I have used try cast. In case if it fails, it will convert into a null value. However, if it is not null column in our clean layer, it will not get into that table. If the clean layer restaurant ID matches with the stream restaurant ID, all the columns will be updated. Otherwise, it will follow insert approach. So let's run this. So I got total 5 rows inserted into my clean restaurant table. So this is my clean, this is my table, this is my restaurant. And if I look into the data preview, I have the data. And if I look into the lineage, I can see the lineage is built. So this is my clean goes to stage, and stage table goes to stage location. Looks good. Now I am creating a restaurant dimension. Very simple. Here I have restaurant HK, restaurant ID, and all the informations are almost same. If you look into the line number 265, I have this effective start date, effective end date, and is current. If the record is coming first time, then this will be a true value. If it is being updated, then this gets the current timestamp of the time of update, and this becomes false. So I am creating this restaurant dimension. This got created, and now I am following exactly the same merge statement. Where going to check if the stream has the new restaurant ID, then it will be inserted. Otherwise, it will be updated. Here it checks. This flag in the stream object allows to change the current timestamp, and is current equals to false. And this update statement, it's into a new insert statement with current date as the effective date, and is current column equals to true. And if it is a completely new data set, then it will be anyhow inserted. And if you look into the hash, we are creating the hash by taking all the column which uniquely identify the record. Now let me run this merge statement. Now it got the 5 record inserted. Let me go to the table view. I can see the restaurant dimension. And here if I see the data preview, so I have all the restaurant 1, 2, 3, 4, 5. They all belong to city Delhi, and my location ID FK is 111. So I'm making sure that this location ID, which is coming as a referential integrity from the source system, is maintained as is for better traceability. So if you look into the system, the data from here got into the stage. From stage, we ran a copy command into the restaurant table. And as soon as the copy command inserted data into the restaurant table, the stream captured those changes. And using a merge statement, data moved from stage table to the clean table. And again, here also we have all the changes captured, and finally it moves to the restaurant dimension table under the consumption schema. So this is how the restaurant data moves. Now let's check the delta data processing. So let me run this list command. So I have two delta data. Let me first pick the first one. So I have record 678, and this should get into the system. Now let me run this copy command. So my copy command got executed and it confirmed that total 3 rows got added. And then copy history also confirms this. Now I don't need to do anything. I can simply go and run my merge statement and the data will go to the dimension table automatically. So this is my first merge statement into my clean restaurant table. So it confirms that 3 record got inserted. Now I am going to run my next merge statement, which will perform the merge operation on the restaurant name based on the restaurant STM from the clean. So I got 3 record added. Good. Now here I can see 1, 2, 3, 4, 5 and 6, 7, 8 looks good. Now if I go to this restaurant name and if I refresh this, I also got 1, 2, 3, 4, 5, 6, 7, 8 and all the is current flag is true for all of them because so far we haven't got any updated record. It is all insert record. Now let me rerun this list command. This is my second day delta. This is my second day delta where 9 and 10 are new record, but 3, 4, 5 are old record with some changes. We do not know what changes are there, but let's see. Now I am running the copy command. So my copy got executed with 5 records where 2 are new, 3 are changes. I am running my merge statement on my clean restaurant. So here it made 2 insert and 3 updated, which looks good. And with that, we can certainly track the stream object. So if I run this stream, let's see what happens. If you look, 9 and 10 are new record because here my flag is false. For all other record, the flag is true. And there are 3 delete in the sense old records are internally deleted and then it is newly inserted. And if I go to a particular restaurant, if I select this, so here this type information got changed. Okay. and all other information here also the restaurant phone number got changed. All other information looks good. So this change should reflect into my dimension table, and for that I need to run this merge statement on my restaurant dimension table. So let's execute this. So it says 5 record got inserted, so 3 plus 2, and 3 got updated. Now let's refresh this. So if you see this, the big chill, here I have two entry for a big chill. One of them should be false and one of them should be true. So first one looks true and this one looks false, and wherever I have a false, I got the effective end date. So I managed to populate second dimension table, looks good. If I refresh my ER diagram, I can see my restaurant dimension and restaurant location dimension. So as we continue to add more and more dimension, this ER diagram will refresh. So we got the restaurant object populated in our consumption layer as a restaurant underscore dim. Now the next we are going to touch upon the customer underscore dim. This is my customer entity worksheet, and so first I am going to create this customer table in the stage location without specifying any data type, and all of them are having a text data type. So this got created successfully. Now as we have done for other entities, we are going to create a stream object. Let's refresh and see how does it look like here. So I got the customer, and if I look into the column, I can see my PII tag. Likewise, in the restaurant also, we had one column. This restaurant phone number also having the sensitive tag, looks good. So this is my initial load CSV file, and this is standard copy command which I'm going to run. So my copy got executed and total 5 customers are loaded. Let's see how this customer file looks like. So this is my customer CSV file where I have total 5 customer as initial load. In the second file, I am having 6, 7, 8, 3 additional customer. And then on the third file, I have 9, 10, 2 customer, but customer 2, 3, 4 have got some changes as we have done for our restaurant just to see whether our SCD2 is working fine or not. So I already got the 5 record loaded. Now I'm going to create another customer table under clean schema. This time I have customer surrogate key, customer ID, and rest of the informations are exactly same. And each of this column got appropriate data type with not null wherever applicable. So let me quickly run this. Now I'm going to create a stream object on my clean customer. Now that is also done. Now as we have done in our earlier entities, I am going to run a merge statement. If it is a new customer, it will get inserted. If it is an existing customer, then it will update each of this record. So my clean layer exactly represent my source data. Now let me quickly run this merge statement. So I got my 5 record inserted. Now customer is also a master information. So I'm going to create a customer dim. Here I have a customer HK, which is a hash key, and customer ID as a standard source primary key, and rest of the information as is. So this table got created. I'm going to follow the merge approach where if the customer dimension will take the customer stream object from the clean layer, and if all the values are same, including the action equals to delete flag, then it is a change and new record will be inserted. And if it is a new customer, then a new insert will happen as a part of this merge strategy. So since we are getting all the new 5 rows, it will insert, and let's go back and check how the customer dimension looks like. So let me refresh it, and I can see a customer dimension available here. And if I see the data preview, so this matches with my data set. So this is looking great. Again, this is all mock data created for our simulation purpose. So let's run this list command first to check the file name. So this is my file name, which matches day one insert customer, looks good. So let me run this copy command. So I ran the copy command and it loaded 3 rows. Now this is my first merge statement. Let me run this. 3 rows got added. Moving to the next merge. This is my customer dim merge. So now let me refresh this here. So I got total 1 to 7. All looks good. Now let's quickly check our update with SCD2. So this is, let me copy the name. So this time I have total 5 entries. Looks good. So in these 5 entries, 2 are insert operation and 3 are update operation. So going to my clean merge. So if you see, 2 record got inserted and 3 record got updated as a part of first customer insert. Now let me go to the dimension merge statement. And here I have got 5 record inserted, which is 3 plus 2, and 3 row got updated, okay, which is expected. Let's go and refresh our customer dim table. Now, if you see some of this customer, like number 2 and number 2 are having 2 entries. So one of them will be false. So this is false and all of them are true. So this is working fine. Let's quickly check the lineage. So the customer dim is coming from customer clean layer, and customer clean has upstream of customer stage, and customer stage has upstream from CSV stage. Looks good. So now let me refresh this. Now when I refresh my ER diagram, I can see my customer dimension is also available along with my restaurant dimension and my location dimension. So we managed to complete the flow for 3 entities. Now, let's see how we can follow the same approach for customer address, which is having a one-to-many relationship with customer dimension. So these are the sample CSV file which we loaded for customer address. And the first file has total 5 address entries. Second file following exactly the same rule where we have a 678 ID for a customer address. And then I do not have any update here. I am just keeping it very simple. So the next records are having a 9 and 10. Okay. So here I am also following the same process. I am going to create the customer address table. Looks good. And next I'm going to create the customer address stream. Now I am running a copy statement and loading the data from this customer address location. Now 5 rows got loaded. Let's quickly validate that. So if I go to data preview, I can see address ID, customer ID, flat number, floor, and there is all the data looks good. So now I'm going to create a customer address under the clean location. So it got created. Now we are going to create a stream object. This is also done. Now I'm running a merge operation as we have done it earlier. And this merge operation again running on a customer address stream. So 5 rows got loaded. Now I'm going to create a customer dimension. Here, this is my customer address HK. And this customer ID, I change the name to customer ID FK. So we know that this is a source system foreign key relationship. Though we are not going to build a relationship here, but I'm just keeping it for better traceability. So my address dimension table got created. Now I'm running the merge statement as we have done for other 3 entities. So my 5 rows got loaded. Let me refresh this. So I got my customer dim, and if I click on a data preview, I have all the data set. Since I have all the updates available, I am directly running from this delta customer address, and I'm not going to run one by one. So since I just gave the root folder name, it loaded all the 5 rows and 2 different files. Looks good. Now I will quickly run the merge statement. So this is the first merge statement on clean layer, and this is my second merge statement on dim table. Looks good. So if I refresh this, I got all the 10 records. Order is not maintained during the copy. So this is how it looks like. So we managed to complete the customer address dim also. So now when I refresh this, I also got my customer address in this ER diagram. Looks good. Next, we are talking about menu object, and here this is my menu initial load CSV file, and I have 2 other files. At the first go, we are going to load around 12 menus. Then on the second delta, I have from 13 to 20, and on third, I have 21 to 26. Again, we are not making any changes here, and this is all one-time operation. So let's quickly create a menu dimension table. So I'm going to create menu table inside my stage schema. So this got created. Next, I'm going to create menu stream. Then we are going to run a copy command, which will pick the CSV file from initial menu location. So 12 record got updated. If I see, I have total 12 record, looks good. And let's quickly see how the data looks like. So this is my menu. Let me shrink. I see copy got executed, and data reviews. I have total 1 to 12 menus under different restaurants, and this looks good to me. Now I am going to create a menu table under the clean schema. And this is my merge statement. Now next, I am going to create menu dimension. And if you look into this, this is menu dimension HK hash key. And I have given menu dimension hash key, which is my enterprise data warehouse key. And this primary key is from the source system, and this foreign key is from the source system. So this is how you can also follow some kind of a column level description to make sure that your users who are doing the development on the top of this table will have a better understanding. So let me create this menu dim table. It got created. Now I'm going to run a merge operation on menu dim by considering menu stream from the clean schema. So total 12 rows got added. Let me refresh this. I can see menu dim, and when I go to the data preview, I can see total 1 to 12 menu item, and here different restaurant, and all those informations are visible. Looks good. Now again, we are not loading individual files because both the files are having only new record. So let me run it quickly. So I can see total 8 and 6 record got loaded. So here I have 8 record, and here I have 6 record. Looks good. Now I will run my first merge on clean menu. So expected number of rows inserted 14. Now running the next dimension merge statement. Now let me refresh this. So I can see all the data set available here. Looks good. Sometimes this does not get refreshed, and if you have to get this refreshed, I have to reload the page. So let me do that. So I can see total 26 entries which matches with this. Looks good. let me refresh this too. So I can see my menu dimension is available here. Looks good. Next, we are going to work on delivery agent, which is another master data set. And these are the CSV file which we have already loaded into our stage location. If you look into the first file, we have total 5 delivery agent. In the second file, we have another 5 delivery agents. And in the third file, it is only updating the first and 10th record just to see if our SCD is working properly for this delivery agent entity. So first, we are going to create delivery agent table in the stage location. Let me quickly create this. And we are going to create the delivery agent underscore STM. So now I'm going to load the data from this initial delivery agent location. Let's quickly validate this. So this looks good. Now I am creating the delivery agent table under the clean schema with primary key auto increment as surrogate key, and the rest of the information looks almost same. Now, like we have done earlier, going to create a stream object in my clean layer to populate dimension table. This got created running a merge statement, very similar pattern. So 5 rows got inserted. So I'm creating delivery agent dim table, and here I have hash key and other primary keys and rest of the columns from the domain entity. So this is created, and now my merge statement, which is insert or update data into the delivery agent dim table based on the delivery agent stream object. So this is a similar process, and now I got my delivery agent dim dimension table created. Let's quickly review. All looks good. Since I have insert and update, I am going to run one by one. So I will first take this, and this is my delta. I'm going to take this and make sure that I run the copy command. So copy command got executed, 5 record. This is my clean layer merge statement. Let me run it. This got updated. Now my next merge statement on the dim table. This also got updated. Let's review this. So I have total 10 record. Great. And now let's rerun and get the second file name. Let me run the copy statement. So 2 rows got added. Looks good. Now they are both update statement. So let's run this clean layer first. It is only update, no insert. Looks good. Now if I go to my dimension table, it will have 2 update and 2 delete. Looks good. So for the 10, I have 2 entries, and for 1, I have 2 entries. So 2 of them will be having false and 2 of them will be having true. Looks good. These are false and these are true. So I managed to get delivery agent dimension table populated. Now let me refresh this. So this is my delivery agent dimension table. So we managed to get 6 dimension table in my consumption layer. Now we are going to process the transaction table, but for the transaction table, we are not going to populate the dimension table. They will represent as a fact table. So these are the dimension table or master data set which we have already populated in our consumption schema, and it is already having slowly changing dimension type 2 implemented. Now This next three set of table are primarily transaction table, and we are not going to populate them as a dimension table in the consumption layer. Rather than they will be created as a fact table. And when we talk about a fact table, we always ask ourselves what would be the granularity. Here, the granularity of the fact table would be order item. So delivery entity, order entity, and order item entity will be populated until in layer, and from there we will create only one single fact, and we also have to create a date dimension before that. Okay, so let's start with delivery entity. So let me change the context quickly. So if you look into this data set, this is my delivery initial load. I have total 8 delivery IDs, and this is my order ID, and this is the delivery agent ID. So starting from 1, 8, they are one-to-one mapping here. When I'm going to 2, I'm having 9, 10, 11, 12, and these are all 9, 10, 11, 12 order ID. When I'm going to second delta file, I have 13, 14, 15, 16, exactly 13, 14, 15, 16 order IDs. Let me first create the delivery table. It got created. Now, as usual, I'm creating the stream object. This is all done. Now I'm running my copy command. So 8 records got loaded, looks good. Now I'm creating a delivery on the clean layer. So it is created. Likewise, I'm creating a stream object. This got created. Now I'm running this merge statement as we have done earlier. So this is looking good. And let me refresh here. So this is my stage delivery, and I will go to clean delivery first. So I have total 8 record, looks good. Now I would not go beyond that because this is my transaction table. Moving to order entity, and let's quickly see how the order entity CSV file looks like. So I have total 8 orders, then I have total 12, 9, 10, 11, 12 orders in the first delta, and I have another 4 orders in the second delta, which is exactly matching with our delivery CSV file. So, and I'm going to follow the same path. So let me change the context quickly first. And this is my order table. Here I have given the column level comment, and I have kept, this is a source system, primary key, FK and FK. So looks good. So my orders table created. Now I'm creating this stream object on orders table. This got created. Now I am simply running this copy statement, and total 8 rows got loaded, looks good. Now next I am creating the orders table in the clean schema. This also got created, and I am running this stream object on my order object on the clean schema. Looks good. Now this is my merge statement, which will merge data on clean schema orders table from this STM. So I have to make it STM. Now let's run this. Okay, so 8 rows got loaded, looks good. Now let me run the delta one by one. I think there is a spelling mistake. This is orders. Okay. Let me quickly check this. Yes, it is orders. So let me run this. And since I'm not making any changes to the orders, I will run both the orders order file first and then follow the merge statement. So got loaded. I have single merge statement because I'm not going to the dimension layer. So total 8 rows got added. Now let me refresh this in the clean. So this is my orders, and this is how the data preview. So order ID, customer ID, restaurant ID, FK. And if I go to the column, I can see these descriptions, and Snowflake also allows you to change the description if you have necessary privileges on the table. Okay, and this is my surrogate key. Looks good. Now moving to order item entity. This is the granularity which we are going to follow to create our order item fact table. Let's see how the CSV file looks like. So this is my initial load having total 14 entries. For you can see here, order 1 has only one item, order 2 has two item, order 3 has one, order 4 has one, order 5 has two item. Likewise, we have that. If I go to second delta file, this also has around 14 records. And if I go to this, I have total another 12 record. Looks good. Again, I am not making any changes here. These are all direct insert statements. So let me create the order item table inside my stage schema. So first, let me change the context. So my order item table is created. I am creating the order item stream object on my order item table. And now I'm running this copy command. So there is some problem. I think so. This is order items. Now I am creating a clean layer order item. And now I'm creating this stream object. So all good. Now this is my merge statement which will read data from stream object and insert into a order item inside the clean layer. Looks good. So 14 rows got loaded. Now here I do not have anything update. So I'm just directly running this copy statement. I can run this merge statement. So 25 rows got added. And let me refresh this. So I got my order item also populated here. And if I say order item here, this is also populated. I can see data preview and I have total 39 rows available. Looks good. Now every data warehouse project needs a date dimension, and that's what we are going to do after creating this transactional table up to clean layer. So to create a date dimension, we will start with a minimum order date, and we will get the order date from the order table, and we'll take the minimum of that, and from there we are going to use a common table expression approach to create a dimension table. If you are not very sure how to use a common table expression, I have a detailed video which shows how you can use a recursive common table expression to populate a date dimension. Now, let me shrink this. So if you look into this date dimension table, I have hash key, calendar date, followed by different date columns. And let me create this particular date dimension. It is created. And if you look into this insert statement, which is primarily taking the minimum value from the order tables, and once it gets this one, it recursively follows the approach to get the date dimension. Let me run this insert statement with the common table expression. Now I got 376 rows inserted. Looks good. Good. And if I come to this layer, so this is my date dimension. I have all the data available, 376 rows where quarter, month, week, days of the year, and everything is available. Good. Now we got all the necessary transaction table up to the clean layer and the date dimension. In the next part of the video, we are going to create order item fact. And before that, let's refresh our ER diagram to see whether all these tables are available there or not. So now I can see date dimension also available. Okay. So I'm going to create a fact table quickly along with the relationship, and obviously it will convert into a star schema. So this is my 12th order item fact worksheet. So first I'm going to create a order item fact table which has a primary key which is auto increment. I can also make it SK surrogate key. Feel free to change as per your requirement, but this is surrogate key, so I will make it SK. And now I have order item, which is primary key coming from the source system, and then it is a order ID and the customer dim key, customer address dim key, restaurant location dim key, menu dimension key, delivery agent dimension key, order date dimension key, followed by some of the measure which I have added here. So let me create this fact table. Now this fact table is created. Now this is a merge statement which is joining all the dimension table based on the FK available in each of the table. And finally, if the record gets changed, then it gets updated. And if the record is a new record, then it is an insert statement. So let me quickly run this. So I can see total 633 rows got added, and let's see how this fact table looks like. So if I refresh this is my consumption schema. The fact table appears here, and I can, this is the complete fact table structure. And if I say data preview, I can see a lot of data available. And this is how there are some null values because there might be some issues with my data, but finally it is showing the quantity and subtotal and everything, right? So the small data set I have, it might have some gap, and that's why we got some null values. So if you have to avoid the null values, you cannot have a left join. You can just keep inner join, and then you will not have a null values in your system. Once our fact and dimensional tables are populated, I'm going to quickly run this alter statement, which will create this relationship. So let me run this. So all of them got executed successfully. If I refresh to this ER diagram, let's see what happens. Now you can see my ER diagram got refreshed, and I have this star schema where at the center of this star schema, I have this order item fact table. And if I click on any one of this relationship, I can see this relationship is built based on the hash key. Now, since my fact table is created, I can quickly create view. We create this view, which is primarily annual revenue, and let's do that. And if I run select star from this annual revenue, let's see how does it look like. So if you see on 2024, my total revenue was 15,454, and on 2023 it is 9,880. 5 orders, 10 orders. This is looking good. Now I'm going to create monthly revenue view, and this also got created. So if I see what is my monthly number looks like, this is how it looks like on the year 2024. This is all month, and these are the sample data looking good. Now if I go and create a daily revenue, then this is my daily revenue. And if I run for 2024 month 7, this is how it looks like. And I am using these views into my Streamlit dashboard, and let's see how does it look like. So here, this is my select year based on the dummy data we have populated. This is my total revenue. This is my average revenue per order. This is my maximum order value, total number of order, and average revenue per item. And if you see the total revenue for all years, number of orders, and maximum order. And this is all the monthly trend, though they are not very well organized, but at least you can see the clear data. And if I select year 2023, the number changes since I only have data for 2 years for this sample data set. It is not showing the comparative analysis. And this is December and November. Okay. So this is how you can really create end-to-end data flow and make sure that you do everything in a single platform. And in the next step, I will rerun the entire script by populating large amount of data, and we'll come back to this dashboard and see how does it look like. let's quickly discuss how this lineage looks like once we create all the object under different schema. So this is my consumption schema, and this is my view, and this is my daily revenue KPI. And if you look into this, this is my daily revenue KPI, and this daily revenue KPI is based on my fact table, and this is also depends on my date dimension, and this fact table depends on multiple dimension object, and that's what you can see here. These all dimensions are upstream object for my fact table. Now, if you look into this order item, delivery item, they are under the clean schema, and this fact table is also populated based on this two object. And from here, I can see my entire lineage up to this stage location. And this lineage diagram helps me to understand where all my fact table is being populated and how I'm creating my view. So this is a very, very useful feature which Snowflake has added as a preview as on today, but maybe in future it will add more and more column lineage and many other enhancement to this preview version. We already loaded a very small set of data, and that data flow automatically build this lineage diagram. Now, I have already loaded the large amount of data under a different database called production, and I have followed exactly the same process what I have already shown you. Now, let me show you what is the data size which I have loaded and processed. So this is my stage location, and if I look into my orders, I have quite a lot of data set available here. And if I go to order item, here you see I have total 41 MB of data size, and I ran exactly the same process what we have done for a small data set under this production database. And if I go to my consumption layer, and if I click on my order item fact table, it has got close to 6.2 million record. And if I click onto these tables, you can see the number of rows as well as the size of the data. So we have total 6.2 million records, and that data set is available from 2019 to 2024, total 5 year of data set available. And now let's see how our dashboard looks like. So this is my project, and this is my Streamlit dashboard, and I am clicking on this Swiggy revenue dashboard. Right now it is getting loaded, and here you see I have total 1, 2, 3, 4, 5, 6 years data set available. If I click on 2019, the data gets changed. So this is my total revenue, this is my average revenue per order, maximum order value, total orders, and average revenue per item. This is my monthly revenue trend for year 2019. And if I hover into this bar, it is showing the exact monthly revenue. And this is the monthly revenue trend. And if you look into the top 10 restaurant for December 2019, this is how the data looks like. I can check. So data gets changed for a different month. Likewise, if I go and choose like 2021, let's see what happens. Now here it shows how much revenue has grown compared to the last year. So you can really use this Streamlit widget, and this is the total revenue. And again, this is all dummy data which I have created to demonstrate this example. Now here this is 2021 monthly revenue, and this is the trend, right? I say February, let's see what happens. So this got changed, and here I can also maximize it and minimize it, whatever I want to do. Now let's see and choose 2020. So the revenue has jumped a lot, and this is how this overall dashboard looks like. And you can create a different kind of dashboard. Once you have this fact and dimension table, you can always take one of the dimension, and around the dimension you can ask different kind of questions and help your business users to get the answer through this data platform. Once everything is done, now it is time to think how to automate the entire flow so it runs without any human intervention. And as soon as the CSV files are dropped into the stage location, this automated job runs, and start processing the CSV file one by one. There are multiple approaches, and we will not practice them here in this video, else this tutorial will be too long. We will only discuss the commonly practiced approach that many data project teams follows. Let's start with first approach. In this approach, each dataset like customer, menu, delivery, and so on will be wrapped inside a stored procedures using Snowflake SQL script. So, if we have around 9 to 10 entities, if I take this example, each of this stored procedure will run the copy command, then run the merge statement to push the data from stage to consumption layer. Now, this individual stored procedure will be called by another parent stored procedure, and this parent stored procedure be invoked using a task, and that task runs once a day or multiple times a day based on the data arrival frequency. Alternatively, the same approach can also be implemented in a slightly different manner, where all the copy commands can be wrapped in a single stored procedures. All the stage to clean merge SQL statements can be wrapped in a single stored procedure, and all the clean to consumption merge statement can be wrapped in another single stored procedures. And then all of these will be called one after another from the parent stored procedures. And this parent stored procedure will be again called using a task based on certain frequency. There are another approaches like creating a DAG using task tree where each of the task is stream aware, so it will trigger only if there is a data available in the stream object. Alternatively, you can also solve this problem using dynamic tables. This video become very long if I start explaining each of these approaches, and if you are really interested to go beyond this video, I suggest you to visit my Udemy page where all these scenarios are discussed and explained in detail with small as well as large data set, so you can download the content and also practice to enhance your Snowflake data engineering skill. Thank you so much for watching. I hope you found this video informative. If you learned something new, please give it a thumbs up and share your thoughts in the comments section below. I would love to hear from you. Don't forget to subscribe for more content like this. Happy learning and keep growing.